All right, we're working on the side frames now. I've profiled the first one, drilled it. I'm going to show you how I did that. I mean, there's nothing fancy going on here. As I did earlier with the propeller, when I'm holding thin stock, the new technique I'm using is to contact cement it down to a waste piece of aluminum in this case. Again, nothing fancy. I'm just using, weldwood contact cement. It's the same stuff you would use if you were working with Formica. Up until now, it's held the pieces really well, so I'm gaining confidence in it. And later, after the part is cut out, I just use a heat gun to loosen it and then pop the pieces off. So we're set up now for a rough profiling operation. And again, it's nothing fancy. When I'm using this technique with the contact cement, I use a very slow depth and feed rate. I certainly don't want to be pulling the thing loose. And then I blow a light stream of air on it. No coolant, just air, just to keep the chips clear. This technique seems to work pretty well. You know, it's funny when I tell people who aren't machinists about using these machines and CNC software and such. Sorry about that. Compressor kicked in, as it always does at the worst time. Anyway, I'll talk fast. When I'm explaining to non-machinists, people who've never used CNC before, they ask, well, high-level overview, what is this all about? And, you tell them that you go to your CAD software and you draw the part, and then it generates some instructions called G-code, and you feed that into, your milling machine, and it just cuts out the parts for you. Which, of course, is a very high-level explanation, and in some respects it's true, but it oversimplifies the process. And if you either are a machinist or you've been watching the rest of the videos, you realize that it's rare that you can just tell a machine or tell the software what you want to do, and it'll do it, and you can sit back and watch. This is one of the few parts where that actually is true. But I always find it funny with my friends who just don't get it, and they think I should be able to knock out a helicopter in a couple of hours or a couple of days, because the machine's doing all the work. But by now you've seen that although it is possible if you have automatic tool changers and all sorts of stuff. But if you're working in a small environment like this, you tend to use CNC to assist you, like I did, with the wizards on the lathe for a lot of projects, or a lot of the parts. Anyway, even though the machine's doing all the work, this is boring to say the least, so all I'll probably do is just speed up the video and let you watch it in a lot less time than it really takes. Well, you may be wondering why the job just stopped in the middle, not even the middle, but it just stopped. And I'm not sure if you can read the message on the screen, but essentially Mach 3 is telling me that it can't find my smooth stepper, which is the USB connection to my hardware controller that runs the mill. And this has been going on for a week or so now, where I've just had these intermittent problems. This is the first time it's ever happened in the middle of actually cutting apart. I've been lucky up until now. It's been happening like in between when I'm doing setup and so forth. So I've been in touch with the manufacturer, and he's got me trying a bunch of things, like reboot and stuff like that. So I'll get back to you when we get the mill resolved. Well, I wasted about a week or so trying different things, software adjustments, replacing USB cables, and blah, blah, blah. And still couldn't get my controller box to work, so I mailed it back to Soy Generous, which is the company that makes this box. It's called an STDR-4C. But what it really is it's a Gecko G540 controller card and a smooth stepper, the USB model of the smooth stepper, which is what connects the Gecko to the PC. And it's a beautiful controller. I mean, the enclosure is probably the nicest enclosure I've ever seen. Front panel couldn't be any simpler. There's an on-off switch and an e-stop button. But what I really like about it is Jeff, who runs the company, has brought all the connectors out to a really nice, back panel here. So it's very easy to set, to connect things to it. There are connectors for your 4 steppers. And then he's also got a place to connect your speed controller so that you can let Mach 3 control your spindle speed rather than doing it manually. Anyway, I was after I lost a week just messing around with this thing, I was in a hurry to get it fixed. So I sent it second day clear across the country, and that cost $50 to get the box out there. And when Jeff got it, he took it apart and he looked at it, and it turned out that all that was wrong was there's a little USB header in here, that brings your USB cable back to the where the smooth stepper is. And that little cable, which is a $7 part, had actually failed, which is of course extremely unusual, but cable failed. So he replaced the cable and charged me $7 to do that. And then we spent another $50 shipping it back. So $100 in shipping and $7 for a throwaway part, and the box is back. So I'm going to go connect this up to my mill now and see if we can, well, first we'll see if it works, and then we'll see if we can get get back to work and finish doing that profiling operation we're in the middle of. All right, well, I plugged the controller back into the computer. I started up Mach 3, and when it crashed, I wrote down the X and Y coordinates that Mach 3 thought we were at. Now I'm not sure if those are exactly right, because I don't know where Mach 3 lost control and when the last time it got around to updating the DROs were. But I just did a sanity check and moved back to moved around, and it sort of looks like it's in the right place. So I'm going to try to restart this job and cut this part over again. And if it's wrong and it messes up the part, we'll just have to start again on that one. But it seems like it's reasonable to just check it and see. So let's give it a go. Yeah, it looks like it's off by a hair. But I'm going to let it run once around the profile and see if we can salvage this part. Otherwise, we'll start it over again. Yeah, this isn't going to work. Yeah, it was worth a try, but I'll have to restart that part. What I'm going to do now, as long as I've got the blank for the skids mounted, I'm going to reset, and we'll cut this out. All right, I've switched everything over and changed so that we can profile the skids here. So no big deal. I mean, it's the same basic operation, just different set of G code. All right, I've completed the roughing operation. It took just about an hour. Because as you saw, I was going very slowly, shallow cuts. And again, that's because the part is only held to the waste piece with contact cement. I'm set up now to do the finishing operation, just to take the last few thousandths off the part. And I'm a little concerned because, now that I've cut away the bulk of the material, all that's left is the thin part here, which is, the skids. And of course, that has very little surface area, so there's very little contact cement actually holding that in place. And even though the finish is only going to remove a few thousandths, there still are, forces at work. But, I can't figure out any good way to get in here and clamp this any better, so I'm just going to wing it. We'll start up the finishing operation and just cross our fingers. Looks like it came out fairly nice. There's just a little bit of chatter at these two edges here, but it's nothing that I can't fix with a little sandpaper. All right, so the part is cut out. The only thing left to do was drill 3 holes in here, to attach this to the underside of the helicopter. And then we can, take the heat gun and remove the part from here. If you watch the propeller video, you've already seen me do this, but if you haven't, you get to see it. I'm just going to use the heat gun to remove the stock from the waste piece. You probably noticed that there's a piece already off here. What happens is the cutting fluid I use for drilling the hole seems to eat its way through contact cement very, very easily. So that piece sort of just fell off just from drilling these 2 holes. So it also probably tells me that instead of using a heat gun, I could probably just use cutting fluid. But regardless, I'll do it this way. Just have to be patient. Alright, that's most of the waste pieces. That's it. Later, when this cools down, I'll just use some mineral spirits to clean off the glue, and then I can reuse this piece. Because we have to make another skid, because another side piece, because the first one got messed up. Anyway, it's as simple as that. What I'm about to do now is attempt to bend the landing skids that we just profiled into the actual shape of landing skids as they're marked out in the plan. I don't have a sheet metal grate or any proper tools for doing this, so I'm going to wing it as usual. So what I've done is the center part has to stay flat and stationary because that's what gets connected to the bottom of the helicopter, and all the bends are away from this point. So I've clamped 2 pieces of aluminum here just to keep that straight, and my plan is to just put this in my vise here. And then I've set this, to the angle I want to bend. And hopefully this will just bend without giving me any problems. So let's just see what happens here. I don't know if I can get enough leverage on it. I think I'm going to need some mechanical help. Give me a place to stand and I'll move the earth. Of course, the problem is that the clamps are now hitting the vise before I've gotten to the appropriate angle. That. And let's see if we can do it from the other side. Fighting me the whole way. Well, that seems to have worked. So the next step is the skids themselves need to be bent just a little bit so that they are, the skids themselves, just this last piece here, need to be bent so that they are in true vertical. I'll just do my side. I should probably move the, this brace down to here. I am in no way recommending this as the optimum approach, but I think bad has happened yet. So. So you can see where we're headed here. I hope you can see where we're headed here. This is now, you know, perpendicular to the top. So all I have to do now is make this one match. It should be set. Right. So, that worked. See that? That wasn't so bad. I had been fretting over this and thinking about wondering if I should make my own, miniature sheet metal brake. And, well, obviously I didn't have to because this is working just fine. All right.